graphing. And what I do is I use GeoGebra, so I go www.geo, see GeoGebra too, but I just want geogebra.org. So geogebra.org. If I go there and I click on software, then there's one called GeoGebra Web Applications or application. I click on that. Now you can use a graphing calculator to do the exact same thing. The concept is, do you know how to graph, and then understand how to find solutions with graphing. And you're allowed to use the graphing calculator all you want, but GeoGebra is just a quick way for me to do this for you than using a graphing calculator right now. So look at example 1, 4x cubed minus 40x. So I'm going to go down to the input and go f of x equals 4 times x to the power of 3 minus 40 times x. Enter. That's what this graph kind of looks like. I want to fix it so I can see it, so I click this one up here, and I can shrink it down so I can see the graph. And then the other one is 6 times x squared. So I will type in g of x equals 6 times x to the power of 2. Down there on the bottom, push enter, and there's the graph. Now if I want to find the solutions, the solution occurs at all the points of intersection. So one here, and one here. So if I click here and go to intersection, click, click, and click. And you're always looking at for what x coordinate are these two graphs equal. So what's the x coordinate of each one of those? And look, negative 2.5, 0, and 4. Now let's go back to where they solved it algebraically. Negative 2.5, 0, and 4. Same thing. So if we want me to do another one, like say this one, I want to see where x to the fourth minus 16 equals 0. So let's go File, New, x to the fourth minus 16. So f of x, or g of x, I guess this looks like what I'm doing, equals x to the fourth minus 16. Enter. I want to see where it's equal to 0. Looks like right here and right here. So I'll just got my dot tool, and I'll click negative 2 at 0, and at 2 it's 0. So at 2 and negative 2. Looks like it doesn't want to make a dot. If I want it to make a dot, all I have to do is do another equation. Since the other side was 0, just put an equals 0, and then I have it on there. And then there's the point of intersection, and there's a point of intersection, but for some reason it's not wanting to do that, but it shows up, so there we go. So I just had to re-click it. So negative 2 and 2. So then if I look here, see part B when they solved it? Negative 2 and 2. Now, the imaginary solution, since it's a fourth degree polynomial, you know that it has 4 solutions. And if it only has 2 real, so 2 of them that show up on the graph, then the other 2 are imaginary. So you would have to know that those 2 are factors and then be able to factor out to get the other 2. This one, x cubed minus 7x plus 21. File, New, f of x equals x cubed minus, now I forgot, 7x plus 21. So I think I can just put 7x plus 21. And it'll graph it for me. So it looks like it crosses the x-axis once, but now I want to see where that's equal to 3x squared. So then I type in g of x equals 3x squared. There. So it looks like they have an intersection here, and they have an intersection here. So the real solutions are negative 2.65 and 3. Go back here and plus and minus the square root of 7 and 3. So why plus and minus the square root of 7? So there's a, oh, because it crosses. If I zoom in, let me zoom in. If this thing's going to let me zoom in, I'll grab this tool. Move my graph over. A little hard to see. But I think if I do it right, and I move in on that spot, crosses right here too. Which is 2.65. So positive 2.65 and 21. So those are your three solutions. So it actually crosses twice in here. That's a little one. That one's a little hard to see. You can see one, but the way to tell is if you have a third degree, x to the third, you're going to have 3. X to the fourth, you're going to have 4. You could do the same on this one if you wanted to figure out where this one crosses. You just put 2 divided by m minus 1 over parenthesis m minus 1 equals 4 over parenthesis m squared minus 1, and then it would find that as a solution. So let's even try that one. New. So f of x equals, and let's just do one at a time, 2 over m, 2 divided by m minus, oops, 2 divided by m minus 1 over m minus 1 and then is that it for that side? Yep, equals 4 over m squared minus 1. So enter, oops, gotta go down here, push enter. Oh, m, it doesn't know m, sorry, x. I think if I would have put f of m, it would have worked. But okay, g of x equals, and I think that one was 4 over m squared minus m. So 4 divided by parenthesis x squared minus x. And again, all we're looking for ever when we do these are the points of intersection. So boom, so where are they equal? See how this can be a little bit of a challenge, apparently. So let's see if I can stretch this. Does that help me? Looks like it crosses right here at 6. Everywhere else, I don't know if it really crosses. They get really close to each other, but if we move the graph around, see, they get really infinitely close, but I don't think it crosses. So if I go right here at 6, 0, or 6, is it 6, 0? Oh yeah, I'll edit undo that one. And then even let's undo that one. So I think it'll even do intersect between two objects. There. So there's your value. Looks like it's, nothing's perfect, but looks like it crosses at 6. And the y value is 0.13. So if you plugged in 6 like they do right here, you get 2 over 15 equals 2 over 15. Hope that helps. Again, you can use your graphing calculator all you want. And you can do all this on the graphing calculator. A little bit of a learning curve though, but if you're willing up on it, you can do that, or use this for now.